Okay, Waka, today we're going to journal page 10, compression and stretch transformations. So f of x equals negative a, parentheses, negative b times x minus h, parentheses plus k. So when a is greater than 1, it's a vertical stretch. When a is greater than 0 but less than 1, basically a fraction, then it's a vertical compression. When b is greater than 0 but less than 1, it's a horizontal stretch. When b is greater than 1, it's a horizontal compression. Okay, if you would, go ahead and update your notes. Okay, notes complete. Let's take a look at the examples. All right. Journal page 10, compression and stretch transformations. Example 1. Graph g of x equals 2x squared and state the transformation. Well, first off, you notice that I've already graphed the parent function of x squared, okay? And you want to graph that first so you understand what the transformation is based on the parent function, okay? Now let's take a look at g of x. But wait, before we do that, let's actually look at the domain and range for the parent function, which we know domain of a quadratic is negative infinity to positive infinity. And then range is bracket 0 to infinity. Okay, now let's graph g of x. So we see here that there's a 2 in front of x squared. Okay, so we're going to plug in negative 2 for x, square it, and then multiply it by 2. So that's 2 times negative 2 squared equals, well, negative 2 squared is 4. 4 times 2 is 8. Okay, then 2 times negative 1 squared is, negative 1 squared is 1. 1 times 2 is 2. Okay, and then that's 2 times 0 squared, which is 0. 2 times 1 squared, which is 2. 2 times 2 squared, which is 4. Okay, so let's go ahead and graph those points. So negative 2, 8. 2, 1, 2, 3, 4, 5, 6, 7, 8. Okay, negative 1, 2. So negative 1, 1, 2. Okay, 0, 0. And then 1, 2. And then 2. I'm sorry, that's not 4. Because 2 squared is 4. 4 times 2 is 8. So 2, 8. Okay. Domain, still negative infinity to positive infinity. And then range is bracket 0 to infinity. All right, the transformation. We know from our notes that this is the a value. It's greater than 1, so it's a vertical stretch. So we could actually just say VS for vertical stretch of 2. Okay, and you can see it's stretched because if you were to pull it vertically, it's going to get thinner. Okay, so go ahead and finish up example 1. All right, now let's take a look at example 2. Graph g of x equals 1/2 x squared and state the transformation. Okay, so again, you notice that I have the parent function of x squared already graphed, and we know the domain of that is negative infinity to positive infinity, and then range is bracket 0 to infinity. Okay, so now we have 1/2 times each of these x squared values. Okay, so that's 1 divided by 2 times negative 2 squared. Well, that's 1/2 times 4, which we know is 2. Okay, so then that's 1/2 times negative 1 squared, which is 1/2 times 1, which is 0.5. Okay, 1/2 times 0 squared is 1/2 times 0, which is 0. Okay, 1/2 times 1 squared equals 1/2 times 1, which is 0.5. Okay, and then 1/2 times 2 squared is 1/2 times 4, which is 2. Okay, so let's graph those points. Okay, so that's -2, 2. So -2, 2. -1, 1/2 is right there between. Okay, and then 0, 0, 1/2, and then 2, 2. Okay, and again, you can see how you're almost like pushing it down, so compressing it vertically. Okay, so then, and actually, let's just go and say that. So we can say that that's a vertical compression of 1/2. Okay, now domain is still -infinity to +infinity, and range is still bracket 0 to infinity. All right, go ahead and finish up example 2. All right. And let's take a look at example 3. And again, if you're watching the video, you should, if you're in Algebra 2 and Advanced Algebra 2, you're still watching for this example page, okay? Compression and stretch transformations on journal page 10. Example 3, graph g of x equals the square root of 4x and state the transformation. Okay, now we first need to graph the parent function, which is the square root of x, so 0, 0, 1, 1, 4, 1, 2, 3, 4, 2, and then 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3. And you always want to graph the parent function when you're talking about transformations because the transformation is based on the parent function, okay? So now here, we're taking the square root of 4 times the x value. So we have the square root of 4 times 0, which is the square root of 0, which is 0. And actually, I always forget the domain range. Let me stop here for a second and come back to domain range. Domain is bracket 0 to infinity, and range is bracket 0 to infinity. Okay, so now we can come back to here. So that's square root of 4 times 1, which is the square root of 4, which is 2. Then you have the square root of 4 times 4, which is the square root of 16, which is 4. Then you have the square root of 9 times 4, which is the square root of 36, which is 6. Okay, so let's graph those points. Okay, so then you have 0, 0, 1, 2, so 1, 2, 4, 1, 2, 3, 4, 1, 2, 3, 4, and then 9, 1, 2, 3, 4, 5, 6. Okay, now we know that this 4 right here is the B value, and we know that when B is greater than 1, it's a horizontal compression. So horizontal compression of 4. All right, example 4. All right, graph g of x equals the square root of x divided by 4. State the transformation. Now, first off, we need to graph the parent function. Now, I'm using a few different values from the parent function, but you can use whatever values you want. But I'm using these because you can take the square root of each of these numbers, and it's going to make sense when you come over here. Okay, so 0, 0, 1, 2, 3, 4, 2, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 1, 2, 3, 4. Okay, so we have the parent function graphed. Domain, still bracket 0 to infinity, and bracket 0 to infinity. Okay, and actually, go back, and I apologize, it seems that I don't know, I guess I'm getting older and I'm constantly forgetting domain range, but let's look at domain range here. Still bracket 0 to infinity, and still bracket 0 to infinity. Okay, sorry about that. All right, now, if I get this to the screen, all right. So now we know that we have the square root of x divided by 4. So we're going to take these values divided by 4 and take the square root. So that's the square root of 0 divided by 4, which is the square root of 0, which is 0. Here we have the square root of 4 divided by 4, which is the square root of 1, which is 1. And then you have the square root of 16 divided by 4, which is the square root of 4, which is 2. Okay, so let's go ahead and graph that. Sorry, I forgot to mark that as yellow so you know that this is that function. Just very forgetful today, I guess. I don't know. All right, so now let's graph those points. So 0, 0, 4, so 1, 2, 3, 4, 1, and then 16, 1, 2. Okay, and since we know that the b value here is greater than 0 but less than 1, it's a horizontal stretch. All right, domains is still bracket 0 to infinity and bracket 0 to infinity. All right, go ahead and finish up example 4 and have a wonderful Wildcat day.